go, here we 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 go.
Hello, hey everybody, and welcome. So this is Containers from the Couch, and this is the show where we talk all things containers on AWS. And today we have a special show because if you didn't catch the announcement last week, we announced support for Windows, running your Windows work containers using AWS Fargate on Amazon ECS. So last week we had a show, which I'll share a link in just a moment, where we demoed and walked through how to deploy a Windows container to Fargate. So, when we talk Fargate, this is a serverless containerized workload, meaning you're not managing the underlying hosts at all. You're just focused on your container, on your application, and then how do you scale that? So we did that through the console, and it was a really good experience, walked through all the different functionalities there. Now, there's another component here, which is how do you, build all of the infrastructure and all of the components around your Windows workloads, which is your ECS cluster, all the networking and all that. And this is where the AWS Copilot CLI comes in. So we have some special guests on the show today that I'm going to bring in. They're really amazing folks that are building the AWS Copilot CLI. They've done some really cool things. So I'm going to start by bringing FA in to say hello and introduce himself.
Hey, hi everyone. I'm FA. I'm a software engineer on the Amazon ECS Developer Experience team. And for the past 2 years or so, I've been working on the AWS Copilot CLI. That's
awesome. Hey, FA, awesome to have you here.
Hey.
And we have Janice, who actually helped build this really amazing feature with the Copilot CLI. So see, I'm giving it all away already, Janice. Go ahead, introduce yourself.
I have nothing left to say. I'm Janice, and I work with FA. And yeah, I've been working on Copilot and helped implement the support for Windows Fargate.
Awesome. And so I was talking in my brief intro, I had said, when we talk about building, containers and then deploying your containers to a production, ready environment, there's a lot that goes into that, right? You have to think about, a cluster and even with Amazon ECS, the concept of a cluster is very different, right? You don't have to upgrade a cluster, right? Your control plane is fully managed by AWS. You don't have to ever think about upgrading and patching and rolling new instances in your control plane. It's all fully managed. So when new features come in, they're just there out of the box, ready to go with ECS. So there's still the concept though of this logical namespace, which is your cluster. Then you have to think about how do you launch your tasks? Do you use Fargate, EC2, right? You have to think about compute, networking, load balancers, all of that. FA, maybe FA or Janice, if one of you want to just maybe talk about how does Copilot simplify all that and make folks like myself, our lives way easier?
Yeah. Janice, you want to start first?
Maybe you should take this one. You can give the
sure. So so with Copilot, right, we have three different concepts. We have an application, which is just means it's a collection of microservices, right? So when you think about building microservice architectures, you'll have many different services that you would like to have, maybe a front-end service, some sort of API service, another back-end service. All of these will be modeled in Copilot as concepts. So you'll have your application, which is the name of your product. Then we'll have the environment. And this is where, like what Adam was saying about all these like low-level networking concepts will be created part of an environment. So we'll create a VPC, for example, for you. We'll create the load balancer. We'll create the security groups. All those like permissions will be created on your behalf in a CloudFormation stack by Copilot. And then at the end, with the type of service that you'd like to deploy. Like if you'd like to create, for example, Janice will show how to create a load balanced web service with Windows containers, right? So that means like an ECS on Fargate service that's behind an application load balancer. You just have to define, you just say that, hey, I want Copilot to create for me a load balanced web service, and that will generate all the infrastructure on your behalf, right? And we'll make sure to connect your load balancer with your ECS service. We'll set up the necessary IAM permissions. We'll set up all the security group stuff, as well as creating the necessary CloudFormation stacks.
Yeah, it's really there's just a lot that goes into it. I think no matter how you look at it, when you're building anywhere, you have to think about all of these things, and Copilot abstracts all of that away from you, and you just have this really nice intuitive interface, which is the CLI, that just guides you through the experience. So so Janice wrote an awesome blog. She's like an amazing writer. I was reading this blog, I'm like, I just wish I could write a 10th as good as this. So Janice basically you're gonna walk us through what you deployed in the blog and go through that, and we'll have some fun.
All right. So the first thing that you want to make sure you have is not only do you need to download the Copilot binary, there is a Windows version available, but you also want to have your AWS CLI installed. So we can just run AWS configure, and we set the account that we want it in and the region that we want to deploy our app in. So once that's ready, I'll show you what we have here. So this is just our source code. We have a Docker file, and that's what is going to help build our container. And then we just have the meat of the app itself. So from here, we do Copilot app init. So I think we should call it containers from the couch.
Yes.
Mm-hmm.
I support that.
So
you just ran a Copilot app init. It's just now asking you to name the application. I guess it says creating the infrastructure. What's happening now under the hood?
So under the hood, Copilot is creating some IAM roles that will enable you to do all the things that you need to do. It's making a subdirectory within your where you are right now, a Copilot subdirectory, and that's where everything that Copilot generates will be housed. What am I forgetting? Okay.
No, I mean, that's correct. And I think at the end, the reason why this step is taking a little bit of time is that we are also creating KMS keys. So what Copilot does is that, we mentioned earlier, we'll create CloudFormation stacks on your behalf, and we'll upload this CloudFormation templates to S3 buckets. Those templates need to be encrypted. So that's why this step takes a while with KMS keys.
So,
and that directory you mentioned, this is where the manifest file will live, right? The Copilot manifest.
Yep. So for every service or job, we generate a manifest, which we will see. So yeah, they live in the Copilot directory. So at this point, we need an environment for our service to deploy into. So we're going to run Copilot init. So let's call it containers from the couch. And here is where you can do things like spin up an environment in a different region than the one the app is in, or in a different account. So we're going to just check to make sure we want to do what we want to do. And we'll just do it in the same one, it's simple. And here is where you can, if you already have a VPC, you can just use that one and use the resources that are within that, public subnets, private subnets. But we are going to create a new one. And
so for those folks, I'm so sorry to interrupt. So for those folks that are if you're, maybe you're well versed in Windows, right? But you're not so well versed in how to create all of your resources in AWS. But you have a container image, you want to get it deployed. Copilot is going to, with this experience, I can bring my own VPC. I can, add some certain customizations, if you will, but I can also just take the path of choosing the opinionated defaults that just come out of the box with Copilot.
That's correct. And just to expand on Janice over here for what we're doing, when we run Copilot Infinite, is that each one of your microservices that you want to deploy to, you have to say with Copilot where you would like to deploy. So do you want to deploy to a test environment? Do you want to deploy to a production environment? In this scenario, we named our environment containers from the couch-env, but in a real world scenario, that will be probably test or prod. And like Janice said, over there, when we were asking which credentials to use, you can choose a different AWS profile. So you can have your production environment live in a completely different AWS account in a different AWS region than where like your test environment might be. And lastly, just like Adam said, you can either opt in with Copilot to be like, okay, Copilot, create everything for me. I want a brand new application, a brand new VPC, brand new security groups. Or if you have an already existing application, right, you already have a production account with existing microservices, and you would like to reuse that VPC while running Copilot Infinite, you can do that.
That's impressive. And you're stitching a lot of, frankly, complex things here. Like when you talk about multi-account, when I say multi-account, I mean your environments may, live in different accounts. There's IAM roles, policies that have to be configured. Like these are things that folks if you're not using this tool, you're figuring this out on your own, and it can be a headache. So that's really cool. So go on, Janice. Sorry.
So what I'm showing here is I just popped into my AWS console to show what is happening under the hood. So Copilot is creating these CloudFormation stacks for us. So that's what is busily spinning away. And you can see that it's still creating. But you can also, things are happening. But the beauty of Copilot is that you don't even have to use your console if you don't want to. If we go back to where we were, you can see that this progress tracker is telling us exactly what is happening and what resources are being generated for us.
Yeah, and there's a lot here, right? Like just what we were mentioning earlier, in this situation, we opted into creating a brand new VPC, a brand new environment with Copilot, right? So you can see that the new VPC is being created. It's going to span 2 different availability zones, right? So we have public and private subnets for each AZ. We create an internet gateway for you. We create all the IAM roles that are needed, as well as your ECS cluster where your ECS services will live.
One thing, FA, is whenever I talk about Copilot, I always talk about how the team is really thoughtful in how y'all, build for our customers and their environments. And one thing that's really cool is, cost is, aside from security, right? Security is always job zero, but then cost is another thing that's really important to our customers. And so there's no NAT gateways here, right? So our customers don't have to pay for things they may not need, right? Do you want to elaborate on that maybe a little bit?
Oh, sure. Yeah. So it's exactly like you said. By default, we won't be creating NAT gateways for you. So by default, when you're launching an ECS service, behind the load balancer, if you want your service to be able to take traffic from the internet and be able to communicate back into the internet, so if you want egress to the internet, we'll place your service behind public subnets. But since security is job zero, with security groups, we'll lock down your tasks so that no one from the internet can make requests to your task directly. It has to go through the load balancer instead. So that's one way that we'll be saving costs for you, right? Like, for example, in your test environment, if you have 1 or 2 tasks that are running, right, and you're not like scaled that high, you don't need necessarily to place your task in private subnets behind with NAT gateways. So you want like a cheap test environment, and that's what we'll create by default for you. Now, if you want NAT gateways, that is definitely possible to do too. I think Janice will show later on like how manifest files can be configured. And over there, you can declare that, hey, I want my task, my ECS service to be placed in private subnets instead. And in that scenario, we'll create the NAT gateways.
Fantastic. All right, Janice, go on.
All right, so our environment has been spun up. And so now the next step is to build the service itself. So we'll do Copilot service init. And there's a little bit of magic happening here. First we'll pick what kind of service we want. So like if I said earlier, it's a load balanced web service that we're creating that will have access to the internet, or it's internet facing. We're gonna sneak peek into what this is, but we're gonna call it Joker. And so here, Copilot looked all around and found our Docker file. So yes, we would like to use this. Another option is if you already have an image that's built, you can just give Copilot the path to that image, and Copilot can use that instead. We are building our image. So this is the point at which Copilot recognizes that you're on a Windows machine and acts accordingly. So you'll see shortly what that means. So it's generating a manifest now that's going to be stored in the Copilot subdirectory. And that's where you can go in and make things sort of customized to what your needs are. So we'll look at that now. So this is our manifest file. You can add health checks.
Janice, I see that port there, and what I didn't see you do was specify port when you deployed, or when you ran the init. Right.
Copilot will read your Docker file to see what port is specified in your Docker file.
That's really cool.
And for Windows, if Copilot has detected that you're on a Windows machine, it will automatically change the CPU and memory to be the lowest required number. Then we have this platform field. So this is where you sort of confirm that you are on a Windows machine. We can specify if we'd rather build, I think we can do full and core. So this is where the default is core, because that is what most people, we think, want to do. So if we just leave this as is, then it'll just build. What else do we have here? You can specify the number of tasks that you would like to run. Yeah.
And just to reiterate, for the manifest file is really infrastructure as code. So instead of generating CloudFormation templates directly, which will have a lot of the individual smaller resources, we're generating infrastructure as code for a particular type of architecture, right? Jess, would you mind running Copilot service in it again, just to show the different types of architecture Copilot provides? Right. So with Copilot, you choose which architecture best represents your type of microservice, right? So in this situation, we chose a load balanced web service, and it means that we want our service to be able to take ingress from the internet behind the load balancer and then distribute that traffic to ECS on Fargate. Other options that we provide, right, are backend services, worker services. So these are services that are maybe strictly accessible in your VPC, or they can consume events from a queue. And the manifest file only provides configuration from the point of view of that architecture. So there is no we don't showcase a task definition or service parameters, really additional configurations that might not be relevant for a particular architecture type, right? If you have a worker service, you won't be having an exposed port, right? So we don't showcase the port, for example, there.
That's a really good point. Go ahead, Janice. You were going to say something.
Just that there are other possibilities that we don't surface in the default manifest that are all listed in the docs that people can look through.
Yes, which link below here. And it's a really interesting point to point that out, though. You don't just get this manifest file that supports, all the different patterns, and I have to sort through, I have to sift through 1,000 lines of a manifest. Now it's just as complex as building the CloudFormation myself, So, and the manifest file is so powerful because if you want to enable auto scaling for your service, it's not like I don't have to think about creating the metrics and doing all of this. And you may go into that, so I don't want to spoil too much, but it's just a really simple annotation in your manifest file, and that's it. You have auto scaling set up. So did I spoil something, Janice? I'm sorry.
Not spoil anything.
Okay. All right, but go on. Sorry.
Okay, so for our particular service here, we are going to build a DynamoDB table and connect to it. So we're going to now run Copilot storage init. So you can run, you can deploy services without extras like this, but in our example, we are going to. So we're going to choose DynamoDB. There are a few options. We'll call it jokes. So this whole experience is sort of as straightforward as can be with the guided prompts. So what just happened was when we ran storage init, Copilot generated a CloudFormation template that will be a nested stack for our service. So if we want to look to see what that looks like, we can. So it is under. Oops. Wait a minute.
The Joker.
Oh yeah. I was thinking containers from the couch, but that's that. So we now have a. Oh, it's right there. So we now have an add-ons subdirectory under the workload name. So this is what the CloudFormation template looks like. Aren't you glad you didn't have to write it yourself?
Exactly.
Yeah. So this basically just does all the things that we need to happen for this DynamoDB table. So after we did a storage in it gave us our the variable name that we can use within our code itself. So it's an environment variable. And I actually already have it in the code because I knew this was going to happen. So I think we are ready to deploy. So now we just run Copilot, service deploy.
And it's building the Docker file. The one thing I wanted to point out above was, and again, I like to point out all the things that Copilot's doing because I just know I've done this, in the past. I know what it takes, and there's an IAM policy there to enable access from your task to that Dynamo table, right? Like you don't just out of the box, you can't just access whatever you want in AWS. It's least privilege model. So by simply creating that policy, which Copilot did in the CloudFormation, it created this little output of the policy name. Copilot figures out that, hey, this is something that I need my service to talk to. So I'm going to add this to the task role, which is the IAM role, which is attached to your Windows container when it runs, right? Just more thoughtfulness from Copilot.
And I think we do a few different options there. So in Janice ran Copilot storage in it to generate the DynamoDB table. So Copilot provides this guided experience for certain types of infrastructure that you'd like to attach a service. We do that for DynamoDB, for S3, and for Aurora serverless today. Or the other option is that, hey, if you like to use, for example, Elasticache, which Copilot doesn't provide by default, you can still write your own CloudFormation template. And at the end, in the output section, if you output the IAM role or a security group or a secret, Copilot will automatically parse all this information and wired back to your ECS task. So that's what Adam was saying, is that the IAM managed policy that was defined in the template automatically gets assigned to your ECS task. So your ECS task can talk to the DynamoDB table. And all this info is also available in the docs.
And a question came in from Amazing Davi. Can you show how you're referencing this table in the code?
Yeah, let's look at the code.
Full disclosure, we're not Windows.
Yeah.
So it's a whole new world for us navigating PowerShell.
All right, so here, for this Flask app, I needed to refer to the table. So just here up at the top, this is the environment variable that was created. So I just set that as the table name. So everywhere in the code that where we need to talk to the table, it just gets injected in there.
And there was just a follow-up. Do I need some other configuration? And I think the answer there is no, right? You did the storage init. You have that CloudFormation template, which defines your Dynamo table. And now you have an environment variable. That's the table name, which, by the way, this is just good practice when working with containers. You don't want to hard code table names, database names into your code, right? You grab them as environment variables. They're dynamic per environment. So Copilot gave you this environment variable to reference the table name, and the rest is up to you with how you call it. But yeah, nothing additional, right?
That's exactly correct. Yep.
Cool.
So while we're waiting for this to build, we can go back and look at what is happening on the console if we would like to do that. Uh-oh.
Hey, David. I don't know why I didn't get a hi, but I mean, I get it. I get it. Janice and FR way cooler. David is on. He helped build Copilot, so he's amazing and here in chat. So say hello to David and Utra. Wow, everyone's here, folks. The Copilot squad is here. Anyway, sorry. Go on.
All right, so we have our environment stack. We have this workload stack, the service, and we have that nested stack for the.
Do you want to click on the nested stack just to show like how it matches to the template that was generated?
Yeah, we try to zoom in. It's hard. We want to zoom in for the audience, but it's hard to see here.
Oh, it's in review. You might need to refresh a few times until it's actually available. Oh, yeah, it'll take some time. But Janice, do you want to switch over to the terminal view and like maybe describe some of the resources that are being created and how they can see like afterwards in the CloudFormation stack itself?
Yeah, so this progress tracker tells us all the things that are being built, including our add-ons stack with the DynamoDB table. Service discovery is so that if you have within an app, if you have multiple services, like say you have a backend service and a front end, a load balanced web service, and they need to talk to each other, we use service discovery so we can do that. I think we talked about the load balancer.
Logs, right? One thing I learned from my friend Marcio, who is a Windows specialist, solutions architect with containers here at AWS, is setting up logging for your Windows containers. And like, that's hard when you're doing it on your own, managing the hosts and all that. So this is something that, again, out of the box, we're giving you logs. It's in CloudWatch, fully managed logs, storage solution. So, I mean, it's pretty awesome.
Yeah, and I just want to talk about my favorite things. What Janice mentioned there with service discovery. since service discovery is set up by default, if you have multiple microservices created with Copilot, they can just talk to each other by default. You don't have to set up any sort of additional networking configuration on your own to figure out how do I have my front-end service talk to my API service. I just want to make web requests to each other. Copilot sets all the infrastructure for you and then injects the necessary environment variables so that you can actually communicate between your front-end service and your back-end service.
Again, right? Like all these things that you don't have to think about. It's just, really easy. And David's just being funny in chat right now, asking about macro services. Is that a monolith? I don't know. What is the... I don't want to get too deep into that.
It's anything that David builds. Yeah.
So now we're seeing the deployment, right? So now all these dependent resources have been built. Now we're just deploying our Windows service. Now, I think Windows containers in general are larger in nature, right? But I think here we're using Python, so it's not as large as a traditional Windows container. Is that right? I don't know I didn't see what the size was on this one, this container image.
I'm not sure either, but it's not huge. Yeah. But I do have one sort of in the hopper that is built so that we don't need to wait. Okay, so I did build it in a different region, so we will go to that region.
Awesome.
And we can explore what things like service show and service status and service logs looks like. So, oh yeah, we were just talking about logs. Let's do service.
And, so we talk about all the things that Copilot builds for you. And I think sometimes folks can see that and think, okay, well, that's great. Copilot, you're awesome. But like, what about the stuff when things go wrong and I need to look at logs? How do I do that? Copilot also has built into the tool visibility into your application, right? So you can see your logs, metrics, and all that good stuff.
Yeah. And actually, we didn't get to talk too much about it earlier, but while in the background, the load balance web service was being deployed, is that this is similar to what you were saying, Adam, with NAT gateways, is that the load balancer is not created by default for you, right? Like when we created our environment, it was just all resources that were free, that's not costing anything, VPC security groups. But if you need a load balancer, right? If you're initializing a load balance web service, then we'll create the load balancer for you at the environment level. And we'll only create one load balancer across multiple load balance web services. So the same load balancer will be shared in your environment across load balance web services. So we'll save costs that way. Each microservice will get its own path. And then similarly, if you delete your microservices, like all your load balance web services, you don't need the load balancer anymore. Then Copilot will update your environment stack. It will remove that load balancer for you and save costs on your behalf.
It's fantastic. So now you have your service that was pre-baked in the oven, ready to go. So now we can see logs. Yeah, show us all the good stuff that comes with I like to call it the day 2 functionality of Copilot.
We also have Copilot Service Show, which tells you which environments your service is in. If it's a load balance web service, you can see the URL that you can go to look at it.
Can I talk to maybe some of the environment variables that Copilot creates for you that gets injected by default?
Yeah, so Copilot automatically, when you create these resources through Copilot, then these environment variables automatically are generated, and you can use them in your manifest now.
Yeah, and in your code. Right. Oh, sorry. We're just really quick. Like when you're talking, like as FA was mentioning earlier, when you're talking to other services you don't want to hard code the service discovery endpoint. You're going to simply use that environment variable to construct your call to that API. And it's just available. Copilot gives this to you as an environment variable. You don't have to do anything except use it.
Yeah, and I was just going to add that, like, in this scenario, we can exactly see what Adam was talking about earlier about not wanting to hard code the name of your DynamoDB table into your code. So you can see that I think Janice has two different environments, one called different region, and then the other one called launch env. And the environment variable jokes name, it gets a different value for each one of these environments. So in your code, you're just you're retrieving the value from the jokes _ name environment variable, and the value gets updated for you automatically.
It's pretty awesome. Are you going to show us this website, by the way? Because I think there's a lot of excitement here to see the website.
Well, okay, can I show one more? Oh, actually, two more. Let's do environment show.
Do it all.
Service status. All right. Let's do it. Whoa, so excited. Let's do this. As the name suggests, it gives us the status of the service. So you can see how things are doing. This launched 5 days ago, which was the day of the Windows launch. That's why I named it launch. Secrets out. All right, so what?
Oh, I think, like, if we increase the count of number of running tasks, if we just did not have one, you would see, like, instead of 1 out of 1, you might have like 10 out of 10 running tasks that are healthy. So the service status command is a way for you to be able to gauge the health of your service.
And if auto scaling was enabled, you would see that in here as well. You would see, if your service is in a state where it needs to scale, you'll see that metric in alarm, and your service is scaling, right? So very intuitive.
So that's just another show command that gives us information about our environment this time.
Yeah, I like to use this because I'm constantly lost with where I'm looking at. And this is a nice way to figure out, like, okay, this is in this environment is actually in this account in AWS region.
Yeah, I always forget what region everything is in. All right. I wonder if this one's done yet. Let's take a peek. Almost. Still pending. So yeah, so once the service has been created, it will spit out your URL if it's a load balanced website. And this is our example of the finished product. So because it is attached to or backed by the DynamoDB, we have persistent storage, which brings us more jokes and more jokes and more jokes. So many jokes.
So basically, your jokes are in the DynamoDB table, and your front end app is just reading those jokes and presenting them.
Exactly. Mm-hmm.
These are good jokes.
I mean, yeah. So that's.
And I was just going to say, the default URL that's generated is this ELB URL. Another way is that if you actually bought a domain name on Route 53 and you like to use that domain with Copilot, you can run. Actually, can you show it, Janice, like how, like, the Copilot app init, like the flags of the Copilot app init command?
Yeah. All right. Actually, so yeah. Mm-hmm.
Yep, exactly. Like the second example over there shows, for example, I bought example.com on Route 53, and then I can run Copilot app init -- domain example.com, and that will give us, instead of getting an HTTP endpoint for our load balanced web services, now we're going to get an HTTPS endpoint using example.com. So, you could have your front end service be just www.example.com, or you could have like your API service to be the api.example.com, and Copilot would handle all of the necessary infrastructure for you. So we'll create the ACM certificate, we'll attach that, we'll wait until that certificate is like validated, and then we'll like attach it to your listeners on the application load balancer, and that's pretty much it.
Pretty fantastic. And, there's other things we haven't talked about, which is, pipelines, right? Oh,
All right.
we have an endpoint.
We do. Let's do it. All right. Oh, so yes, we have that as the main site. And then, what
And we
happened?
broke the app. Nothing better than when we break things here.
Do you want to try to troubleshoot it maybe with service logs, just to see if we can figure out what might be happening?
Yeah.
I like that.
I'm acting shocked, but it was all part of the plan. Just kidding. Oh, we're still on the wrong. All right, let's go back to this first. Ah,
Oh, interesting.
logs is so helpful.
It's actually really good. Good troubleshooting. So we can't access the table.
Oh.
I see it.
Ah. Because the table was in the other region. Maybe.
So, go ahead. So it's probably something when we were creating this, we switched over to the other region, ran some commands and did it. So it's just, we deployed to the wrong region, basically, the table.
I think if you open up the code, I saw earlier in like server.py at the top that the region set part of the DynamoDB client was hard-coded to AP Southeast 1. So I think if you change that to US West 2 and then when Copilot deploy again, it will work.
So it looks like FA knew and didn't tell anyone.
It was too late.
That's right. I hard-coded the region when that was the only region.
But this is a great point. So it's like it's another one where like you don't want to hard code, like these sort of values like the table name or the region. I think ECS by default will actually inject an environment variable called AWS underscore default underscore region. So you could just use that environment variable instead, so that you guarantee that stuff will work. Cool. Oh, Janice, I was going to say, you also like part of this implementation, you like not all features of ECS are supported, right? With Windows Container. Do you want to touch up on that?
Sure. So when you run service init and Copilot detects that you are on a Windows machine, it alters your manifest slightly, not only to change the CPU and memory values, but also to disable or to hide EFS and exec suggestions or options or defaults, because those services aren't supported, or Windows isn't supported by those services. So those you can, if you were to try to go in and add them to your manifest, then Copilot would kindly yell at you to tell you you can't do that. The other thing that hasn't been enabled yet are pipelines. So in Linux, we can create pipelines through Copilot, but not for Windows yet.
Good to know.
Yeah.
Good to know. So these are features that we'll be, we're working on. I know, for example, like ECS exec. If you're not familiar with ECS exec, it's just a way to execute a shell into your container running on Fargate. So with AWS Fargate, you don't have access to the underlying host. So, and generally that's good practice, right? You shouldn't be execing into all your containers. But of course, there are times where you need to. So with Linux, that's supported. With Fargate Windows, it's not. However, we are working on that, in a future enhancement to Fargate with Windows. So keep an eye out for that as well. So cool. So we deployed an application. We broke it. We figured out it was not because of Copilot. It was because we hard coded all these best practices we were talking about. We didn't follow. I'm just teasing. But that was actually like really cool when you think about this. If, Adam, I look back at Adam 10 years ago. Yes, I'm speaking, about myself in the third person, like that's really cool. But I remember 10 years ago, I was in operations. I had to manage Windows, Linux hosts, and managing Windows hosts was always hard. There's Patch Tuesday. There was all these things you had to think about with securing them and managing them. And by moving the management layer one level up, where AWS manages the underlying host, and all I think about is, here's my application. It runs in Windows, .NET, whatever that is, that the framework that I like. And Fargate's going to manage that host for me. It's really great, right? I don't have to manage that. Now with Copilot on top of that, I don't have to think about building all the other AWS resources that are basically, right, they're all fully managed anyways, but I still don't have to think about that. So we just keep making it easier and easier for folks to just onboard their containers to AWS. And I love Copilot, and I think this is a tool that for folks that want to get started with containers, you want to get a production-ready environment up and running quickly, Copilot's going to be there for you. And it's not just for POCs, right? This is a tool that will support you for when you're in production. We have customers running their containerized workloads in production today using Copilot. I don't know if we can name drop any of them.
I think there is a case study that was out where I don't remember the number off the top of my head, but they have hundreds of microservices that are launched with. So eCal is the name of the company, and they have a case study that's available on our website where it showcases that they're running several hundreds of microservices, all managed through AWS Copilot.
Yes, Utra handled it. But that was a really cool story, because this really speaks to a company that's lean, right? They don't have a huge operations team to build and manage container orchestration clusters and all of this. They have a very small DevOps team. They want to support I think it was the number was, I don't know, millions of transactions per minute, second, whatever that was, but it was a lot of transactions that they're dealing with. And Copilot helped them get to production really quickly, and they're able to operate in a production environment because of Copilot, and it saved them a lot of time, money. It's pretty awesome. So I guess at this point, I think we had a couple questions which we touched on. David blessed us with his presence. It's always fun having David in chat. But if there's any other questions from the chat, please feel free to ask now. Otherwise, I think we can wrap up. Is there anything y'all want to part with? Any parting words for those in the audience?
We are open source, and we have a GitHub repo. So feel free to contribute, open issues, ask for things.
Do you want to show just the URL of the repo, just the page that's for a GitHub repository?
Me or Adam?
Oh, since you're sharing your screen, maybe if you just navigate to the browser, yeah.
Oh, I even have it. Look at how prepared I am.
Yep.
I was waiting for this moment. Okay, so here we are, our GitHub repo. We also have our docs here, and we are on Gitter/Jitter. There's some debate on how you pronounce that word. So.
I think Gitter is correct, but FA and I want to stick with Jitter. So
you do you.
That's exactly it. Thank you. I appreciate that support, Janice. So I shared the link in chat. So, and they're really modest, but honestly, this is, I say the Copilot team is really like the shining star for AWS, because their communication, they're open and out there on GitHub. If you have questions, you have issues, go to the Gitter, go to GitHub, open an issue, submit it. You know, there will be someone there, a real human that will answer your question and support you. So they're such an awesome team. I love working with the Copilot team and can't wait to see all the other cool stuff we're going to build in the future. So on that note, I think we will wrap up. Thanks everybody for joining. Again, the links are in the blog. If you have any questions, you can always reach out to us on Twitter as well. You see our Twitter handles here in our name. But F.A. Janice, thank you so much for being here today. It was awesome.
Thank you for having us.
All righty.
Bye.